Okay, this is number 12. And number 12 says the population of the world in millions in certain years is given in the table below. Determine the rate of change of population over the 60-year period beginning in 1940. State the unit of measurement. Show the setup of your calculation and your final answer. So anytime they're talking about the rate of change of something, they're talking about the derivative or the slope. So we're actually wanting to find the slope starting at 1940 to 2000. And the way you can think of that, this would be my x values, here are my y values. And if you remember, it's the difference of your y's, and you may see it written like this, difference of your y's over the difference of your x's. Okay, so it's actually the difference from this point right here, because they want us to start at 1940. So we're only looking at this set of data. And we're always going to use our largest number minus our smallest number, basically, over our largest number over our smallest number, but we're going to put our y's on top, y's on bottom. So it's going to look like this. 6,080 minus 2,300 over the difference of our x's, so that would be 2,000 minus 1940. So you can think of it this way. I have two ordered pairs. My ordered pairs would be 1940 and 2300. And my other ordered pair is 2000, 6080. So the difference of my y's or the difference of my x's. And this is going to be, let me see here, 6080 minus 2300. That's going to be 3780. And then 2000 minus my 1940, that's going to be 60 years. And then when I subtract those, I'm sorry, divide those, I get 63. And it says, state the units of measurement. Well, 63 million, because it's in millions. That's going to be the rate of change, 63 million people over years, per 60 years, or whatever they want us to do. It's going to be over our years, 63 million people per year. So it's going to change 63 million people over years. All right, the next one, object's position on a horizontal line is given by this. Determine the average velocity. So you should have learned a basic, like an equation over what determine the average velocity, what that is. It's the position, the change in your position over the change in time. Okay, so average velocity is the change in your position, and that little triangle stands for the change in, over the change in time. So what I want to do is I want to find out what my position is at 3. Here's my position at 1, and then divide that by 3 minus 1. So when I plug 3 in here, okay, I get 3 over 2 plus 3, so that's 3/5. So I have 3/5 minus my position at 1, so I'm going to plug 1 in here. So that's going to be 1/3 over 3 minus 1, which is 2. So 3/5 minus 1/3 is going to be 4/15. Divided by 2 or times 1/2. So that's going to be 4 over 30 or 2 over 15. That's the average velocity. And so he may want meters per second on that. So let me check that and make sure I didn't enter something in wrong. Divided by 2. Yep, 2/15. So that's A. All right, part B. is find its exact instantaneous velocity at t equals 2 by using the limit definition of a derivative. Okay, probably not going to like this. The definition of a derivative, this should look familiar, I'm hoping. F of x plus h minus f of x all over h. Okay, and this is the equation they were working with. T, and then what was my 2 plus t? Okay, so they told us to find the velocity at t equals 2. So here is my limit definition. But I know I want to find when t is 2. Well, in this equation, instead of using t's, they're using x's. So I'm actually finding this. The limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Now here's what that means. That means you're going to take this 2 plus h and plug it into these t's. That's that first part. Minus f of 2. That means take 2 and plug it into this. So it looks like this. First, I'm going to plug 2 plus h into both of these t's. So I have 2 plus h over 2 plus t, but t is 2 plus h, minus, so that's this part. Now I'm going to find f of 2. That means plug 2 into these. 2 over 2 plus 2, and that whole thing is over h. All right, so here's what we're finding. We're finding the limit as h approaches 0 of this. So I'm just going to kind of simplify this. That's 2 plus h on top, and that's 4 plus h on bottom, minus, what is that, 2 over 4? All over h. So now I need to find the common denominator here because I'm supposed to subtract them. My common denominator would be 4 plus h. So this fraction right here, my common denominator is this. It's missing a 4, so I need to multiply this top by 4. So, because my common denominator should be 4 times 4 plus h. So to make it look like this, I have to multiply the top by 4. So that's 4 times 2 plus h minus, this one is missing the 4 plus h. So that's why I'm going to multiply the top by 2, 4 plus h. And now this whole thing is still divided by h. So I'm just going to say divided by h. So I'm still finding the limit. I'm going to use a different color here. The limit as h approaches 0. Now I'm going to simplify this. Distributing my 4, I have 8 plus 4h minus, distributing my negative 2, I have negative 8 minus 2h. All over, I'm going to distribute my 4. That's 16 plus 4h times 1 over h. So instead of dividing, I'm going to multiply by the reciprocal. And that's the limit as h approaches 0. Now I'm going to simplify this. My 8's cancel, and I have 4h minus 2h, so that's going to be positive 2h. And now I have h times 16 plus 4h. Do you see that when I multiply this h times this? So now these h's will cancel, and I have this, the limit as h approaches 0 of 2 over 16 plus 4h. And now I'm supposed to find the limit as h approaches 0. So now I can use direct substitution and plug 0 in here. So when I plug 0 in here, my 4 goes away, and I have 2 over 16, which is really 1/8. So you did all that work. 1/8 is your answer to the question, find its exact velocity at t equals 2. So it's 1/8, whatever my units was. What was that? Meters per second. Now here's the real yucky thing. Next chapter, he's going to show you a huge shortcut so you don't have to do any of this. Okay, let me see how long this is. Okay, find the domain of the function. So we're going to graph this. So I'm going to graph y equals, make sure you're in radian mode, sine, and then tangent -1 means second tan, and then I need my x in there. Okay, I'm going to graph this in the standard viewing window. And I just want to know how far to the left and how far to the right does this graph go. What I see, it goes all the way to the left, all the way to the right. There's no breaks in the graph. So for part A, my domain are all reals, or he'll probably have you write negative infinity to infinity. Part B says simplify the sign of the inverse of tangent as much as possible as an algebraic function. Well, here's what I would do. I'm going to graph the sign of tangent, inverse tangent. So basically, since this is positive, I don't know if you remember from trig, but everything is always positive in this first quadrant. Okay? And here's my angle theta. Well, if you remember, tangent is opposite over adjacent. So they're saying that tangent of some angle x, okay? So they're saying my opposite side is x, my adjacent side is 1. So my opposite side is x, my adjacent side is 1. So now, using the Pythagorean theorem, I can figure out what this side is because a squared plus b squared equals c squared. So we're going to say my a is 1, my b is x equals c squared. So to solve for c, the side, I take the square root of both sides. So c is that. So this side is actually 1 plus x squared. So now they want to know, what is the sine of this angle? Well, the sine of that angle, sine of an angle is opposite over hypotenuse. Well, so opposite side is x. The hypotenuse is the square root of 1 plus x squared. And that's my answer. Okay, I think I'm going to stop right there.